Assalamualaikum. My name is Nur Afika binti Muhammad Asri.
And my name is Nur Amira binti Zahari.
We are from Group 803 and today we are gonna do our class assignment.
Yeah, our class video assignment is number 42.
So enjoy watching!
Question 42. A police officer is investigating the scene of an accident where two cars collided at an intersection. One car with mass of 1,100 kg moving west had collided with a 1,300 kg car moving north. The two cars stuck together skid at an angle of 30 degrees north of west for a distance 17 meters. The coefficient of kinetic friction between the tires and the road is 0.80. The speed limit for each car was 70 km per hour. So the question is, was either car speeding? Okay, we know there is a two car moving in two directions, north, south, east and west. The first car with a mass, we label it as M1 with 1,100 kg, is moving to west. And the second car, we label it as M2, the 1,300 kg is moving north. Okay, we know that this car is colliding. Okay, after collision, the diagram will be like this. Okay, this car was stick together, M1 and M2, and skid at angle 30 degree. So this is 30 degree. Okay, the distance between the distance that they skid was given d equal to 17 meter. Okay, so the question is okay, the coefficient is 0.80. The question is about, we want to know the final velocity because we want to know was either car speeding, but we didn't have information about the initial velocity of the M1 and M2. So the two unknown, we have three unknown. V initial of the second car and the final velocity. So first we want to know the final velocity because we want to use the value to put it up in a formula to find the initial velocity of the two cars. But there is a frictional force exerted between the tires and the road. So the total force in component Y is equal to 0. So the net force is N minus mg equal to 0. So we got N equal to mg. Is M1 plus M2, as we know that the car is stuck together at the end. So the N is M1 plus M2 times with G. So the frictional force that we get is, the formula is frictional force equal to mu times with M1 plus M2 times with G. Okay, so because it is the frictional force, the work done is non-conservative. Work non-conservative is equal to delta KE. Delta KE is kinetic energy final minus kinetic energy initial. Kinetic energy initial in this formula we want to use is as immediately after collision. So immediately after collision, the V is the final velocity of the situation. Okay, so the VF. So the kinetic energy final is once car have skidded to a stop. So when it stop, the kinetic energy is 0. So the formula we will get 1 over 2 mvf squared is 0 minus with 1 over 2 mvi v initial squared. So we substitute the value, we get the final formula is the frictional force time with D equal to 1 over 2 times with M1 plus M2 times with V initial squared. So we derive the formula, we get this formula at the right side. So we substitute all the value and we the mu is given in the question equal to 0.80, and the G is negative 9.8, and the distance is given 17 meters. So the answer we get for the final velocity of the situation is negative 16.33 meter per second. Negative is show is moving to the west. Okay, we found the final velocity and we want to use the value to find the initial velocity of the two cars. Okay, the two cars, because it has two cars with in the two direction, we can divide it into the component X and component Y. For the component X, the initial velocity is negative because it shows it is moving to the west. Okay, so the formula is this. Okay, we substitute the value, and the VF is equal to VF cos 30 degree, because so the VF is in the component X is VF cos theta. The theta is 30 degree. So we get that, we substitute all the value and we get the answer is 30.9 meter per second. But the speed limit is in the unit kilometer per hour, so we change it to the unit, and we found that the first car was speeding exceed the speed limit, which is given 70 km per hour. Okay, for the component Y, we use this formula, and the initial velocity of the first car is 0 because the first car is moving at the X component. So at the Y is equal to 0. So VF sin 30 degree. So we get the answer 54.3 km per hour. So the second car was within the limit. That's not the answer of the initial velocity of the two cars. So the answer for the question was either car is speeding is the first car, because the initial velocity is equal to 111.24 km per hour. So we hope that all of you can understand our explanation. Thank you for watching.